Hello, I am Lili Alamshenas, and today Alexander Gadin and I will be presenting you a proof. So, our given is that there's a parallelogram A, B, C, D, and that AF is congruent to CE. Now we have to prove that these two lines in the middle make a parallelogram FBED. Okay, let's get to it. Okay, so we're going to use these sides, to prove opposite congruent angles and opposite congruent sides so that we can prove that this is a parallelogram. Okay, now we have our space to write it. Now let's just add our diagram. Okay, now we can start. Okay, so our first step is the given. So as set up here, it's now here, and we have the reason, which is the given. And now we can show you our next step. Okay, our next step is that DA is congruent to CB. So DA is congruent to CB. And this is because opposite sides of a parallelogram are congruent. The next step, which we'll show you. And so our next step is that angle DCB is congruent to angle DAB. And again, this is because of opposite angles of a parallelogram are congruent. And then let's go to our next step. Okay, so now this is what we were getting to. So we now know that the triangle DAF is congruent to the triangle BCE. And this is because of SAS postulate. So we already had two sides, and then we were able to get one angle. So SAS side angle side. And now we can go on to our next step. Okay, our next step is that DF is congruent to EB. Also, AF is equal to AC. And this is because of CPCT. And this is important so that we can prove it. Okay, so now we can say that CD is congruent to AB. And this is because parallelograms form two pairs of congruent opposite sides. And here's our next step. Okay, our next step is that DE plus EC is equal to DC. And also that AF plus FB is equal to AB, equals AB. And this is segment addition postulate. Now we can go on to our next step. Okay, so DE plus EC is also equal to AF plus FB. And this is substitution, property of equality. And this is extremely vital and important to our next step. Okay, our next step is that DE is congruent to FB. This is because of subtraction. So if you do the math, then you will get DE is congruent to FB. And here it is. Okay, so now we can say for sure that FBED is a parallelogram, because if there are two pairs of opposite congruent sides, then the figure is a parallelogram. And we have two opposite congruent sides, so now we can definitely say that this is a parallelogram. So thank you.
This is Ariel, and I approve of this message.